Okay, now that we've done that, we've just checked out our oscilloscope, made sure it's working okay, and we showed how we can measure voltage with it, just like a voltmeter. Now we're going to look at some a signal, which is where we have a changing voltage. That's what a signal is. It's a changing voltage. And in our little online tutorial here, it describes how that works, and it describes some of the things we can measure with an oscilloscope. Like we can measure the amplitude of a changing signal. In other words, how high a voltage does it go and how low does it go? That's called amplitude. How high does it, how much does it change up and down? And then we can also measure time as well. That would be the period of our wave. So we're going to use the oscilloscope to find the amplitude or peak, which is from 0 to its maximum. And we're also going to do peak to peak, which is twice that, which is the very top to the very bottom. And we're going to do period, which is the time period for one complete cycle. And we're going to do frequency. We're going to calculate the frequency. The oscilloscope doesn't give us that directly, but we can easily calculate it. Now, we're going to go step by step here. First thing we're going to do is we're going to connect the probe to the calibration output of the oscilloscope. And this is usually a small wire loop that sticks out. So that is this thing here. I'm going to take my probe here and I'm going to connect it to the calibration. Now notice what the oscilloscope did when I did that. It started putting a signal on the screen there. I'm going to move that signal up on the screen like that. And you notice the picture's not steady. It's moving around. So what you do to fix that is you use the trigger here. This is called the trigger, and you adjust that till your picture is steady. The purpose for the trigger is it tells the oscilloscope when to start drawing the picture on the screen. And you can actually see where it's starting to draw it if you move the screen sideways. If you use this control over here, this is called the horizontal position control. If you move it sideways, you can see where it starts to draw right here on the left side. And if you turn up the brightness really bright, kind of gets blurry when you do that, but you can actually see where it starts to draw the trace. It's kind of dim right in there, but if you change the trigger level, that's this knob right here, if you change it, you can actually see it where it starts to draw it. See, I'm moving it down, and then when you either get too high or too low, it loses trigger. The scope stops triggering anymore, and then it just free runs. In other words, it just starts drawing arbitrarily at a certain time, and it doesn't draw the traces so they overlay on top of each other. And that's why you get this circle you get this display that's not steady. It's moving across the screen. So the trigger is a nice thing, because without the trigger we wouldn't be able to have a nice steady picture on the screen to look at. It would be unstable. Okay, I'm going to move the position control back and move the picture back to the center here and take a closer look at this. It asks us to look at that signal and determine what kind of a signal is it. Is it a sine wave, a square wave, a triangle wave, or sawtooth wave? Well, what would you call this what kind of a wave is that? Is that a triangle? Is that a sine wave? Is that a square wave or sawtooth?
Square wave.
Yeah, that's a square wave, isn't it? So we are going to just answer for that one, square wave, of course. All right, next it says, what is the peak-to-peak voltage of the calibration waveform? To do this, count the number of divisions from the bottom peak of the wave to the top peak. To calculate the peak-to-peak voltage, multiply the vertical height of the waveform in division squares by the setting of volts per division. So what I'm going to do here is we're going to measure this, the peak to peak here, by counting the number of divisions. So we have going up, that's volts. Volts is up and down, that's the vertical. So we go 1, 2. So that's just exactly 2. And then we'd multiply that by the volts per division here, and that would be 1 volt times 2. So what would that be then?
2 volts.
Yeah, that would be 2 volts. All right. Now we're going to measure the period of this. The period is the sideways. Right? That's the time going this way. Now, as it appears right now, the display that I see here, the waves the periods are very close together on the screen. So what I'm going to do is I'm going to adjust the time per division to make it, enlarge it a little bit in the time dimension, in other words, horizontally. If I make it wider like that, it makes it easier for me to measure it. So see there, I've made it quite wide, and I can get a more accurate measurement. Now what I'm going to do is I'm going to count going across the screen horizontally. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and about a half. Almost 10, isn't it? Not quite. Maybe you could even call it 10, but it's about 9.5 there. So what does that mean? You see, what that is, if I go down to a lower, what we're looking at is if I go to a different setting on my time per division, I can see more cycles on the screen at once. What I'm looking at is I'm going from right here to right here. That's one complete cycle. Now when I look at it on that setting, it looks like one cycle is 1, 2, 3, 4, 5 divisions. Just about exactly 5 divisions. Of course, I've also changed the setting on the time base here too, the time per division control. Well, how do I use that? What I would do is I would take the number of squares I have here, 1, 2, 3, 4, 5, or divisions, number of divisions, which is 5, and I'd multiply that by what the time per division is set to, which is set to 0.2, in this case 0.2 milliseconds per division. So you would take 5 divisions multiplied by 0.2 milliseconds. So what's 5 times 0.2? That gives us, yeah, it'd be 1, wouldn't it? 0.2 times 5 is 1. 1 what? Well, it's 1 millisecond. So what this is telling us is that the period of this wave, starting here and ending here, is 1 millisecond, or very close to 1 millisecond. That's my time for one complete cycle. 1 millisecond is the period, the time of one period, and that repeats. So this from here to here is 1 millisecond, and then from here to here would be another millisecond, and so forth, and it just keeps repeating like that.